morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. In this video class, I am going to teach you about a role of lexical analyzer. Role of lexical analyzer. So what is meant by lexical analyzer? Last video class I taught you the phases of compiler. The first phase is lexical analyzer phase. What is meant by lexical analyzer? Lexical analyzer is used to convert source program into tokens. Clear? One example also I have given, that is position colon equal to initial plus rate star 60. This is the line, one line of source program, and it is converted into token like ID1 equal to ID2 plus rate ID3 star and 60. Okay, so this is the token ID1 equal to ID2 plus ID3 star 60. This is the way the source program is converted into tokens. Okay. Now, role of lexical analyzer. What is the role of lexical analyzer? That was I am going to teach you today. Role of lexical analyzer. So, lexical analyzer. This is the lexical analyzer. Lexical analyzer. You know, the second phase is the parser analyzer or parser or syntax analyzer. Parser, you just remember parser, analyzer or syntax analyzer or parse tree or syntax tree, both are same. Okay. Okay. Now, symbol table and lexical analyzer is used to convert source program into tokens. That means the input of lexical analyzer is source program like position colon equal to rate star 60, and the output of lexical analyzer is token. Okay, and lexical analyzer scans the program or convert the program into token line by line or one by one. Okay, for example, position colon equal to rate star 60. First it convert position and converted into token and given to the parser. You know, the second phase is a parser analyzer or a syntax analyzer. Parser is used to create a parse tree. Okay, once the first token is created, first source program is created into token given to the parser. Then the parser needs the second source program or second token. It call the next token using get next token command. Clear? See, lexical analyzer, it scans the program and convert into token line by line or one by one. Okay, first it convert and given to the parser. If the parser need the second token, it ask or it call the lexical analyzer using the command get next to token. Okay, and during the conversion of source program into token, it takes the symbol from the symbol table. Clear? It takes the symbol from the symbol table. Okay, and this is the second phase or parse tree. This is the third, fourth, etc. Clear? And it has another responsibility also. The first one is it is stripping out the commands. Stripping out the commands. Okay, it means in a program we have a command line also, right? For example, int a. So double slash, I will write like int is a is an integer. Okay, so this a is an integer line should not be the part of the program. So it should not be executed. So it should be avoided. So whenever the compiler see double slash, after that it should be avoided, stripping out. Okay, so this role and responsibility also performed by the lexical analyzer. Clear? And the second one is first one is stripping out the commands. Second one is it collects the errors created by the compiler. It collects the error and it given to the that role is also performed by the lexical analyzer. Okay, so this diagram you should draw and you want to explain the diagram, right? Lexical analyzer, token and parser. When it need a token, it asks a get next token, and symbol table. Whenever the parser or lexical analyzer need a symbol, it taken from the symbol table. Okay. So the next heading is inside the role of lexical analyzer, you should write parser versus lexical analyzer. Lexical. Okay. These two phases, that is lexical versus parser. Lexical versus parser. analyzer, parser analyzer. Okay. So here my question is, can I combine these two parser? Why sir? These are separate phases. Can I combine these two phases into one phase? So it is easy only, like that we have raised a question. But the answer is, many programming language need a different parsers. Some programming language, it doesn't need a parser phase, it need only lexical analyzer phase. Some programming language, it doesn't need a lexical phase and need a parser phase. So in this situation, if we split the phases into two, it is easy. Clear? It is easy. So simpler design. First one is simpler design. Simpler design. So here you have to write, if it is a separate phases, we can design a compiler simply. Simpler design. Okay. First one is, first characteristics are first parameter. Second one is compiler efficiency is increased. Efficiency increased. Compiler efficiency increased. How we can increase the efficiency is using some buffer. Using some buffer techniques. Buffering techniques. Okay. We have why we are using buffering technique is, see, this is a lexical analyzer phase, and it convert into token. We know token, right? So this phase is always convert the source program into token. So whenever one token is created, it should be stored in a buffer. 2 seconds also is stored in a buffer. So whenever parser need, it can directly taken from the buffer. Okay. So that is simply that will increase the efficiency of a compiler, right? And third one is portability is increased. Portability is increased. We have a lot of tools to design a compiler. We have a lot of tools to design a lexical analyzer. So the duty of lexical analyzer, pass source program into token. Duty of parser analyzer, token into pass tree. So these duty should be performed by some tools. Okay, lexical analyzer, that is called lex tools, that I will teach you in the next session, lex tool. And parser analyzer, yak tool. Okay, yak tools. So these are the tools which is to convert source program into token. Lexical analyzer, lex tool, yak token into pass tree, yak tool. So if you use this tool, compiler portability is increased. Okay, right. So 2 headings you have to write, and third one is you have to write the definitions. Okay, what is meant by tokens? What is meant by token, pattern, and lexeme, right? And token is a sequence of pair consisting of token name and a optional attribute value. So it consists of token name and attribute value. So example I told, if it is position, we have converted token into identifier ID 1. So ID is a token name, identifier or expression, anything else, and 1 is a attribute value, ID 1, ID 2, etc. Okay, that is a token. So token consists of token name and also attribute value. And pattern is a describe the description of the format of the lexeme. Okay, so one example I will tell you. If I write int, okay, int is a keyword. So int is a lexeme, is a keyword. Okay, so what is pattern is, it describe what is int. So I will write character of I and n and t. Okay, what it says, the int means it is a sequence of character I and n and t. It means it describe what is lexeme. It describe the lexeme. Okay, it describe the lexeme. What is lexeme? Lexeme means int. I told you. Lexeme is a sequence of character in the source program. Sequence of character in the source program. For example, int is a lexeme, if is a lexeme, and number, number, sequence of characters. These are lexeme. Clear? So what is token? It consists of attribute name and attribute value. Okay. What is pattern? It describe what is lexeme. What is lexeme? It is a sequence of character in a source program. Everything is called as lexeme. Clear? Okay. Next, one example of token, lexeme and pattern. You have to write one example of What is token? Token, pattern and lexeme. Okay, few example. I have given 4 or 5 examples. You can write 1 or 2 examples. Okay, if is a token, okay, and pattern is character of I and F. Okay, lexeme is if. Okay, what is if? Is a token, attribute name and one identifier, right? Like ID 1. 1 is optional, attribute value and attribute name. This is attribute name, if attribute name. Okay, and character of I and F. It describes the what is token. And lexeme is sequence of character in a source program. If is a sequence of character in a source program, right? Another one example, else, like similarly sequence of character E, comma L, comma S and E, else. Okay, so else is a lexeme. Similarly, you just write some few more example also. Clear? And the last one is attribute of the token. So role of lexical analyzer, you have to explain what is a lexical analyzer and the diagram, and you have to explain. Then second one is you have to explain that pattern, lexeme and token, and third one is you want to explain attributes for the token and parser versus lexical analyzer. Now attribute for the token, it is nothing but I have given one example, E equal to MC square, E equal to M into C into 2 MC square. You know this equation, right? E equal to MC square. So how this value should be present inside the symbol, attribute, how this attributes mapped into the symbol, right? So you know E is an identifier, ID1 or ID, the pointer points to the symbol table, E. Okay, it means what E, how it is mapping or attribute, how it is find as ID1 identifier. This is E is an identifier. Pointer point to the symbol table entry E. This identifier points to the E in a symbol table. Similarly, M means ID2 or identifier. Pointer points to the symbol table entry M. And star is an operator star. Similarly, C is a ID3, pointer point to the symbol table entry C. Star is an operator. 2 is a number, constant number 2. Okay, this is an attribute for the token. So if they ask what is role of lexical analyzer, you should draw the diagram and you want to explain what is lexical analyzer, get next token and parse tree. Okay, and symbol table. Then you have to explain what is the parser and lexical analyzer, why it is separating. Then third, you have to explain the token, pattern and lexeme. And fourth, you have to explain the attribute for the token. Okay, thank you.